I'm going to walk you through solving a system of inequalities today, at least a system of linear inequalities. So let's jump right into this. We're going to take a look at number one here. And notice we're given two inequalities. So I'm going to start with my first one here. And I'm also going to go with primary colors here, and maybe you'll see why in a moment. I'm going to go with blue. All right, so I want to graph this bad boy. Y is less than or equal to negative x minus 2. So first thing I'm going to do is I want to look for my y-intercept here. It's just like graphing in slope-intercept form. So I get my negative 2, and help if I wrote. Excellent. All right. Now for my next step, I have negative x here. So I can always pop into 1, which means my slope is negative 1. Go down 1, over 1, boom. Got a point. Gonna make a few of them. It's always good to do that. Get a nice straight line going. Just like so. And now I'm going to graph my inequality. Now it's telling me that y is less than x minus 2. So what I'm going to do is I'm going to look for my y-intercept values that are less than negative 2. If you'll notice, they're all below here. So I probably should have, I'm going to fix that, no big deal. So since they're all below, I'm going to color everything down here beneath my line. There's always another way to check it too. Some people get a little mixed up with that strategy, so I'll show you another one. What you can do is you pick a value on either side of the line and see what happens. So I'm going to go with, I always like going with 0, 0. So I can plug in 0, 0 here. I'm going to do it in blue too. So that means I can go to my inequality here. I'm going to plug in 0, 0 for each of my values. So I'm using the origin here of 0, 0. Y would be 0, and x would be 0. So let's see, if I simplify this, I get 0 is less than or equal to negative 2. Now, if this isn't true, 0 is not less than or equal to negative 2. So since this value, or this coordinate, would not work for this inequality, that means all this up here doesn't work. So I am not going to shade it in. And then I can always plug in a value beneath it just to see how that would do. So I can do that. I'm going to plug in, let's see, 0, 3 right here. I like using zeros whenever possible. So negative 3, excuse me. So I'm going to plug in negative 3. This is my 0, negative 3 here. Plug in negative 3 for y, 0 for x. And let's see what happens here. Simplify it. Hey, what do you know? Negative 3 is less than negative 2, which is why I'm able to shade everything down here, just like I did. All right, so I've just solved that first inequality. Now, to solve a system, you're going to have to solve the second one as well. So I'm going to shrink down this stuff here. So I'm going to have to solve the second one. I'm going to do this one in red. So I have y is greater than or equal to negative 5x plus 2. So I'm going to go to positive 2 here. And since my slope is negative 5, I'm going to go down 5. 1, 2, 3, 4, 5 over 1. Hey, it's nice. I got a nice little point here. Just make sure I did this right. I think I might have done something wrong. Let me double check that. So I go down 1, 2, 3, 4, 5. Okay. And then over 1. Good. So it's good to double check your work. And now I can make a nice line here. And go up. Do the same thing in the other direction. Go the other way. All right, so now it's telling me y is greater. So I can look for my y values that are greater here on my y-axis, and they're all going to be up here. So I can shade that in, just like so. So that would be the solution to the second inequality. And again, I can use the same strategy I used before by plugging in values to see what works. Now, hopefully you're noticing something here. What's happening is that I have an area down here that I shaded in twice. And that is ultimately what the solution to your system here is. Now, what does that mean? That means I can plug in any of the values in the shaded region right here, anything I colored in down here, any of the values in this shaded region will work for not just one inequality, but both of them. And how can I test that? I can always try the coordinates of one of these points, which I'm going to do. I've got positive 2, negative 5. Unfortunately, I don't have any zeros to work with. But I should be able to plug this into both my inequalities and it'll work. And let's see what happens. So my first one, y is less than or equal to negative x minus 2. I'm going to plug in, let's see, I've got 2, negative 5. this is negative 5 is my y. I'm going to plug that in. And then I've got positive 2 here for my x. Now if I plug it in, I get negative 5 is less than or equal to negative 4. Hey, that's a true statement. That works for my first inequality. Let's see if this works for my second one. So I have y is greater than or equal to negative 5x plus 2. So I'm going to use my same points again. So negative 5 for my y value. And then for my x, again, I'm going to use 2. And I can just solve. Negative 5 here, that's easy. Negative 5 times 2 gives me negative 10. Negative 10 plus 2 gives me negative 8. Negative 5 is greater than negative 8. What do you know? Check mark. So I know that this area right here is my solution set because all the values in here will work for both my inequalities. And that's ultimately what you're doing when you are solving a system of linear inequalities. Looking for that area that gets shaded in twice. I hope this helps.